Hi, my name is Chong Wenshen, and my student ID is 0382047.
Hello, my name is Ko Jianjun, student ID number 0384446.
Hi, my name is Yuan Kang.
Hi, my name is Brandon Yap Kaiser, and my student ID is 0383582.
And today, we're gonna talk about events and probabilities. What is events? Events is what we choose. Probability is the chances of what chances of getting this. Okay, in this video, I'm gonna talk about two examples. Number one is my Lego set. Number two.
The example will be our Galton board game.
So, in this example, I'm gonna talk about my Lego set. Number two.
The example will be our Galton board game.
So, what is events? Events is what I choose. For example, event A, I choose this. Event B, I choose this. Event C, I choose that. That's events. Probabilities. When this kicks in, it's very interesting topic. So, we have two choices. One is equal, one is unequal. Okay, so equal. 1, 2, 3, and 4. That's equal because everything will be chosen. Number 2 will be unequal choices. For example, 1, 2, 3, 4, and 5. Why is it unequal? Because we have 3 motorcycles and 2 cars. This is unequal because we are most likely to choose these 3 motorcycles instead of these 2 cars. This is unfair. This is not fair choices, which is unequal. So, for the second example,
So, for the second example, we're gonna talk about Galton board game. This related to probability because it's seen a marble to drop which section to get the prize. So why is it related? They use this application as to maximize their profit by the store owner in the carnival. So what's the steps of like playing this Galton board game is that we put a marble on top of the board game and then we wait for it to drop. So the marble will be like dropping down, come here, go there, drop again, go right, go left, left, and then until it drop to the final position and to get your prize. So the price it depends. It can be the best, it can be the worst. There's a probability observed in this board game.
Let's talk about probability by looking at this fascinating pegboard. The event in probability is simply an outcome we're interested in. In this case, our main event are the ball land in position 1, the ball land in position 2, and so on. So let's consider the event the ball land in the first position, as the first diagram clearly shows there is only one single path that lead to this outcome. The ball must bounce left at every single peg. There is no other way, so the number of ways this event can happen is 1. Now, let's look at the event the ball land in the second position. The second diagram shows us something very different. For this event to occur, the ball can take not 1 but 7 different paths. It has more sequence of left and right that will successfully deliver it to the second slot. So, what does this tell us about their probability? We can't calculate the exact probability. Yet, because we don't know the total number of all possible paths, but we can already see a crucial part of it. So the probability of the ball landing in the second position is 7 times greater than the probability of it landing in the first position. Why? Because there are 7 paths for the position 2 to compare to just one favorable path to position 1. As we continue to map the path for the other position, we will see the principle created a classic probability distribution, where the most probable events are those in the middle, with the most path leading to them.
Now we will look at where will the ball land. So how do we know where the ball is most likely to land? In the Galton board, each pack represents a binary choice, left or right. As the ball falls, it makes a series of random decisions. The final positions of the ball depends on how many times it goes left or right. By analyzing all possible paths, we can count how many ways the ball can reach each slot. These counts from a binomial distribution, and in this case it matches the Pascal's triangle. Now let's look at the numbers. What is the probability distribution of the final positions? There are a total of 128 possible paths the ball can take. The number of paths to each slot is for slot number 1, 1 way, slot number 2, 7 ways, slot number 3, 21 ways, slot number 4, 35 ways, slot number 5, 35 ways, slot number 6, 21 ways, slot number 7, 7 ways, and slot number 8, 1 way. So the probability of landing in each slot is the number of ways in that slot over the total possibilities. So for slot number 1 will be 1 out of 128, for slot number 2 will be 7 out of 128, slot number 3 will be 21 out of 128, and slot number 4 will be 35 out of 128. And we can continue it so forth and so forth. Now notice that the middle slots 4 and 5 are the most likely, which are 35 out of 138. So the owner will usually put the best price at the sides, which are slot 1 and slot 8, and progressively lessen the price to the center, which is 35 out of 128. So is this game fair? So let's do the math. Now let's talk about the money. The entry fee is 15 ringgit per play. The prizes are a toy car worth 150, a Pikachu toy worth 80, and a Coca-Cola worth 5 ringgit. We can calculate the expected profit for the store owner for each slot. So how do we do that? For slot number 1, for the toy car, we can have the amount needed to play, which is 15 ringgit, minusing the cost of the toy car, which is 150, multiplying the possibility of it happening, which is 1 out of 128. So that will give a price of negative. The owner will lose 1 ringgit and 5 cents. So for slot number 2, which is the Pikachu, we have 15 ringgit minus the cost, which is 80, multiplying it by the possibility of it happening, which is 7 out of 128, and it will give the owner a loss of 3 ringgit and 55 cents. But from slot number 3 onwards, we can see that if you pay a price of 15 ringgit minusing the cost of the Coca-Cola, which is 5 ringgit, and then you multiply it by 21 out of 128, then the owner gains $1.65. And for slot number 4, if it is nothing, for slot number 4 and number 5, the owner will gain a total of 4 ringgit and 10 cents. So now if we were to add them all up, the total expected profit is about 2 ringgit and 20 cents per game. So in the long run, the store owner makes money, even if a few players were to win big.
Now, I will using perspective of expected value for store owner with probability of outcomes to detail explaining when set out Galton board game. Firstly, we can calculate the expected value about the first position hit by the ball. That is 1 over 128 times 15 ringgit minus 150 ringgit, and the result will be negative 1.055. Next, we have the expected value of the ball hit the second position. It is 7 over 128 multiplied by 15 minus 80. We'll get negative 3.555, and the next two positions are third and fourth. It will gain a positive expected value as 1.645 and 4.102, and we can observe that the expected value of next half part position is symmetric as previous half. Sum up them together, and we can know that every single round store owner can earn RM 2.27 average, and that is the expected value for single player only. In actual situation, there are usually plenty of gameplay from customers, about 100 to 1000. Store owner will higher possibility to earn much. Lastly, before ending the part of the video, I advise don't trust too much that you can earn much from much of gameplays as possible, because these games are actually take control by store owner with probability rule. If you trust too much on it, in long term you will have higher chance to losing much money due to facing a game which expected value negative for you.